All right. Hey, good afternoon, everyone. Before we get started, I thought we would do some introductions first. So my name is Tim. I'm one of the engineers on the Java and Copilot teams. And so I work on a variety of different things that I'm going to show some of you today, including some of the app modernization work, as well as Copilot for some of our IDEs that are related to Java, JetBrains, Eclipse, and so forth.
Thank you. And I'm Julien Dubois. I work in the developer relations team where I lead the Java team. And I mostly work on AI, and that's also what I will be showing today.
All right, cool. So we got a couple of things that we want to talk about today, and so we'll get right into it. A lot of it will be demo-based, and so hopefully you'll get to see some of the stuff, and we'll talk a little bit deeper about how some of the things work. Before we get started, I wanted to share with you this slide. I'm sure you've all seen this before, but this is roughly like a breakdown of time allocation for developers. And you know, as a developer myself, I would say that this is actually a little bit generous, right? Like, I don't really think I spend 40% of my time coding. Maybe some of you do. But the reality is I spend a lot of time doing things that I don't really want to do or need to do. And I don't spend enough time doing things that I want to do or that I need to do. And so today, our goal with Copilot in general, and with some of the things I'm going to show you today, is really how do we get Copilot to do more of the things that we don't want to do or that we don't really need to do or spend our focus on, so that we can spend more time doing the things that we want to do or that we need to do, or that the things that are really important for the business. And that's really going to be our goal today. That's going to frame all the things that we're going to talk about. And so we're going to do two things today, like I said. The first thing we're going to do is we're going to talk about AI-assisted modernization and migration. What that really means is I'm going to show you some of the tools that we've built that are powered by AI that helps you modernize your application to get it ready to run on Azure. And then afterwards, Julian's going to come up and talk about, now that it's running on Azure, how do you infuse AI into your applications? And the cool thing is that the same technology is going to power both of them. And so we'll get started with AI-assisted modernization and migration. Okay, so this is the only slide that I have. We'll get started with this topic. And I'm going to shorten the name, GitHub Copilot App Modernization, to just AppMod. It's a very long name, so I'm going to say AppMod. And so we're going to talk about how we use AI in our products today. So if you were on the keynote yesterday, our EVP Jay kind of demoed a very brief 1-minute kind of really high-level overview, and we're going to go into that a little bit more detail today. But what I want to show you is the tools that we built on top of Copilot. It helps us with a few things. One is about code assessment, to understand code. I don't know about you, but I'm responsible for a lot of different apps, and a lot of times I'm not really quite up to date on it, right? Like maybe because they're old, or maybe because I just don't have time to kind of really be on top of it. And so code assessment is really about leveraging AI to help us understand our applications better before we start doing work on it. The second thing that we are going to talk about today is upgrade. And when we talk about upgrade, what we really mean is Java JDK versions and related dependencies like Spring Boot. So we're going to show you how we used AI to help build upgrade tools to help you upgrade your application. And then the other thing that we're going to talk about is about migration. And when we use that word, what we mean is moving your app to run on Azure. And there's a couple of different things that are needed in that scenario. One is upgrades or changes to the app itself. And the second thing is changes to dependencies. And so we're going to talk a little bit about how AI tools can help with that, and you're going to see an end-to-end demo. And then the third thing that we're going to talk about is really about best practices and how to customize best practices. And so that's really exciting. Jay didn't get to show that to you yesterday, and I hope to show you how you can create your own best practices so that you can use the power of AI for migrating and upgrading your own applications. So those are the things that we're going to cover. All right, so I'm going to go straight into a demo, and I will show you from here. Sorry, I have to unlock. And hopefully that works. All right, great. So this is the app modernization tool for Java. It's right here. As you can see, there's a bunch of stuff here, and I am going to go and introduce them as we walk along. And so the first thing that I want to show you is simply this, that this is a starting off point for assessments, and this is a starting off point for code remediation. And we also have it built into Copilot. So if you go into Copilot and you go to agent mode here, if you're not familiar with agent mode is basically the ability to introduce tools into GitHub Copilot so that its reasoning model can kind of select tools and execute those tools to help with the prompts that you've asked. And so here, you can see that these are the Copilot tools, and we've introduced tools for modernization right here. And these are the tools that we have here. And so I want to show you how that works right off the bat. It's pretty straightforward. I'm going to tell Copilot to assess my application using, and here when you do that, you kind of get like the autocomplete using my tool. And so what this is going to do is this is going to tell Copilot to do an assessment of this application. It's going to go and ask me for some confirmation of configuration, and I can just accept the defaults. And now Copilot's going to go and do an assessment. So what it's doing underneath the hood here is it's using a tool called AppCat. AppCat is a traditional tool. You might be familiar with it. It's based on static analysis. If you've used AppCat, what AppCat does is that it generates a ton of issues. And oftentimes what we hear is that, man, the issue list is really long. It's not really organized. It's really hard to make progress with. And so what we've done is we've taken those results, and then we have used Copilot to summarize these results into actionable things for developers. And so as this runs, hopefully it won't take too long, you will see that it's going to come back with a list of results. Okay, so there's processing all the things here. You can see it down here. And then so now it should come up with a summary. And what it's going to do is it's going to categorize all of these issues. For example, it's going to categorize them into things that kind of make sense to developers, jobs to be done. For example, here's some stuff I have to do for database migration. It detected that there's a RabbitMQ use. It detected some storage issues. It detected some local resource access. It also said that, hey, your Java version probably needs to be upgraded. And so now I can click on this, and then it goes and it tries to map these issues into solutions. And so it says, hey, what kind of solutions do you want? I'm just going to accept the default and ask it to find me all the solutions. Okay, so I'm going to tell it to find me all the solutions. And what it's going to do next is then it's going to say, like, okay, what are all the solutions that this tool has for you to use? And for the solutions that we have, you'll see an orange button. And that is an AI-powered, a Copilot-powered solution that's going to do the migration. For the solutions that we don't have, you'll see a green explain text. And that's going to go and ask Copilot to explain and give you step-by-step guidance on how to perform the task at hand. And so if you scroll through here, you'll see that we have a lot of different solutions. And I'm going to show you this first one, which is Java Upgrade. So this is upgrading your Java version into either 17 or 21. And when you click the button, what it's going to do, it's going to send a prompt to Copilot. And I'll show you that right now. And so if you don't want to type into Copilot, you could use our UX. If you want to type into Copilot, you could type in right here directly. When I click this button, you'll see that it's going to send a prompt. Right? So it sends a prompt for me. Upgrade this project to Java 21 and Spring Boot. And now it's going to go and do the Java upgrade. This is all powered by Copilot. What we do here is we do kind of best practice for guiding an LLM. We ask it to create a plan. Oh, there's unwanted changes, sorry. Let me just say, you know what, I'm just going to commit this. So that's the cool thing with Copilot is that it does not want that. Okay, I am going to just revert this. Okay, and so I'm going to continue. And it's going to. And so when you do this, Copilot's going to go and execute a bunch of tools to make sure that your machine is ready to run the upgrade. And obviously, it is doing something that, all right, so it's having trouble with the commits. So here, what I'll do is I'll show you a version of it completed. And so it actually takes a little while. It takes about 5 minutes. But here is a completed Java upgrade. So this app is now upgraded to Java 21. And you can see all the steps that Copilot took. So it generated a plan. It asked you to review the plan. It performs an initial upgrade using Open Rewrite, which is an open source tool with recipes that helps you with things like a JDK upgrade. And then it goes through a build fix loop. And this is where we use Copilot to help us. And so whenever Copilot detects an error generated by an Open Rewrite recipe, it's going to go and try to fix the error using a set of custom instructions and knowledge bases that we've created to guide Copilot along the path. It checks for CVEs on your libraries, and so it wants to make sure that if you need to upgrade your libraries, it'll upgrade it for you. And then it runs tests, and then that's it, end to end. And so it reports the progress over here as you go along. And so that's Java Upgrade. And you can use that, again, it's released, it was released on Monday, and so you could use this right now to upgrade your applications to Java 17 or to Java 21, and associated Spring Boot versions and other dependencies. All right, so let's move on to migration, moving your application to run on Azure. Sorry, that was... So I'm going to start from here again. And now what I want to do is I want to show you how we can address some of the other issues in our assessment. And if you look here, one of the other issues it said was, I want to move to, it says you should upgrade your database. When you move to Azure, one of the things that we recommend is we recommend using Managed Identity to secure your database. And so here I'm going to show you how our tool helps you with that. So I'm going to go and confirm the solutions again, and then I'm going to pick the database migration. And so now I'm going to hit migrate here. Again, when I hit migrate here, you're going to see it send a prompt. You can send a prompt, or you can type it in yourself, but I'm just going to hit the migrate button because I'm a little bit lazy. And now it's going to go and do a modernization plan. And so here's the plan that it's going to do. It's going to look for files, and it's going to identify all the changes to each file, and it's going to handle any changes, and then it's going to do a build. So I'm going to ask it to run. And while it's doing this, and so you can see that it identifies some files, and now it's going to go and make changes to all the different files there are. The way we've taken migration is that you can see on the left, or on the bottom left, there's a bunch of formulas. And formulas are kind of the knowledge that we give to the tool to instruct Copilot on how to make changes that are oriented for the migration. Later on, after this demo, I'm going to show you how to create your own formulas. But you can think of formulas as basically, like sample code, maybe links to documentation, maybe some rules like do's or do nots. Maybe some specific guidance if you have some specific preference about using a service. So for example, with something like a queuing service, you might have in your knowledge base some rules around how you handle failures. Maybe you use a dead letter queue, or maybe you log errors and you don't retry. However your approach is, you can encapsulate these in the knowledge base to inform Copilot so that Copilot can generate code that matches your expectations. And so here it's basically going through and it's generating, it's making changes, and you can see it go along. If you've used Copilot before, you can kind of see it go and make changes. And now once it's done, it's going to ask us to do the build fix loop. This is the same build loop that you saw, or that I didn't show you, but you saw the outcome of in the Java upgrade. And here I'll show you what it looks like. You just hit go. It's going to do a Maven build here. And then it's going to make sure that there's no errors. I believe here there should be no errors, and so it should just succeed. Right, and then because there's no errors, it's now going to go and proceed to do a summary. And so this is, and so if there was an error, that's where our build fix loop will come in, where we identify what the error is, and then we use Copilot to fix the error. And again, the way we do that is through another knowledge base. And this knowledge base is really about Java errors, like how do you fix this error? And we give Copilot some instructions on how to fix that error. And so that's it. So here you can see the code changes. This one is a very simple change because it's really just about dependencies and configuration for managed identity. And so this one is not too difficult. I'm going to show you a more difficult one after. All right. Now, one of the reasons why we wanted to build into Copilot is because now you can actually take advantage of other tools that are available in Copilot. So one of the questions you might ask is, well, okay, now that I have this app building, how do I deploy it, right? And so because it's built into Copilot, because all of our tools are oriented around Copilot, I can actually come in here and I can say, deploy. If you look here, there's going to be a set of tools around Copilot for Azure. So this was released, I think, on Monday. And Copilot for Azure is a set of tools that help you actually deploy your application to Azure. In this case, what it's going to do is going to analyze my application using Copilot. It's going to discover what are the Azure assets that I need to create. And then it's going to generate bicep files for you. And then it will deploy the application for you. And so I'll kick it off here. But I'm going to show you, because it also takes a little while. So the way you get it started is you can simply say this, please deploy my application to Azure. And so here you see that it's going to reference tool, give me 1 second. Okay, so now it's going to reference the tools here. And you can see that it's going to use the Azure tools to kind of figure out best practice. And it's going to analyze our application. And it's going to do all of these things. And I'm going to show you an instance of it being completed here. Again, you see here I told it to help me deploy this application to Azure. And then here's a set of things that it did. It got the best practice. It looked for deployment best practice. It generated bicep files for me. It made sure that the environment and infrastructure was correct in the bicep files. Here it detected that there were some changes it needed to make, and then it updated all the bicep files. So it took too long there, and then it just kept going, right? So here it just kind of and then it created Azure.YAML. So if you're familiar with AZD, the Azure Development CLI, so we create a tool, we create an Azure.YAML for you to deploy, and then it updated the README file for you. And now you can actually go and run AZD provision. And it will provision using the bicep files that it was generated. I can show you what the bicep files are here. You can see that it's generated here. And this is just going to deploy this app onto Azure. And so here you can see how all these different tools that we have come together, right? So oftentimes we kind of think of the tools as being used in isolation, but with Copilot, one of the cool things is that all these tools kind of come together in this Copilot experience. And so with a single experience, you can upgrade your Java applications. You can migrate them to take on Azure dependencies. You can inspect them and generate a corresponding bicep file that will create Azure infrastructure for your application. You can inspect it and generate an Azure deployment file, an Azure.YAML, and have it deploy on provisioned Azure resources. And all of these things you can comes together inside GitHub Copilot. All right, so I want to show you something else before I hand it off to Julian. And it's this, which is all of these formulas here are what we call, we define them, Microsoft made them, right? And these capture kind of like Azure best practices. Now, those best practices may not be compatible with your best practice. And so one of the things I'm going to show you is how to create your own formula. So in this application, when I showed you, this is the same application, there was actually 2 projects in here. There's a web project and a worker project. Now, I'm going to show you how to create your own formulas. Now, in this is a demo, of course. But in this demo, so I click on this button, and that goes to the create formula. And this shows me a list of commits. So what we can do is we can analyze commits, and we will do some Copilot work, some prompting LLM work, to discover what you encapsulated in your commit, and we'll create a formula from that. And so here I'm going to go and look. One of my coworkers, they prepared 2 commits for me, and they're both on the web project. One of them is to convert the RabbitMQ use to Azure Service Bus, and the other one is to convert AWS S3 integration to Azure Storage. And so this is done in the web project. Okay, so I'm going to go here, I'm going to go and say, okay, I want to create a formula from these 2. So I hit OK, and I hit create new, so I'm going to say test 2025. Oh, was that not? Create new, sorry, create new. OK, I don't want that one. And now what we're going to do is we're going to go and examine the GitHub commit history. We're going to analyze it, and we're going to pull out the information that we think is good for a formula. I should have clicked this before I started talking. Okay, so that's fine. All right, and so here is this formula. And the cool thing is that you can actually open these formulas and you can edit them. And so here's an example of one. I'm going to look at the Java file one. And you can see that what we did is we just created a set of instructions, right? Like change the Java files, here's the code patterns, here's the file patterns, here's some steps, and here's some diffs, right, to help. And over time, we're going to improve these rules, obviously. But this is just a starting spot for us. But what's cool is I can go here, and I can then run this, right? And now it's going to apply the same changes using the instructions in that formula generated from the commit. It's going to apply these to the second project, which is the API project. And I'm going to hit continue. And now it's going to go, and you can see here it's going to be changing the second project. So this is the worker, sorry, not the API, the worker project. And so this is an example of how, maybe in your organization, somebody's already done the work of some migration task or some jobs to be done there, and you want to capture it into a formula so that you can automate those same changes in another application. You can imagine that you might have 3 or 4 applications that you can run this Test 2025 formula on, which captures your organization's way of using Azure Service Bus. And that might be different from Microsoft's best practice on Azure Service Bus. One of the final things that I'll talk about here is that you saw SWE Agent from Satya's keynote. We're working on integrating this into SWE Agent. And so that means that in the future, you can even take your own formulas that you've captured and then go to SWE Agent and tell GitHub Agent to run your migration using these formulas, and that will migrate all of your applications using the custom formulas that you created. And so this is some of the work that we're doing to try to really reduce the amount of toil that we have to do. Migration and remediation, those types of tasks are often very repetitive, right? And so the ability to create your own formulas and then to use Copilot to reapply them over, and then to do SWE Agent to do it in the background over hundreds or maybe thousands of applications, we think can really help reduce the toil for the engineers in this group. All right, so I'm going to go ahead and switch back to the slides here. I covered these in the talk, I didn't switch to this. But we've been working with some customers on this already. So we've been working with Ford, and they've been piloting our tool. And I had a chance to talk to them, and it helped them reduce the 70% of some of their migration effort. Now, this is not all of their migration effort, to be honest. This is, they had some specific tasks that they were doing, and they did a A/B test, right? They had some guys working on it without the tool, and they had some guys working on it with the tool, and they found that when there are guys that were working on it with the tool, it was about 70% faster. And here's another one with a telecom company in China, and again, it's a very similar thing. This one is about Java upgrade, right? And so they use our tool to really help them expedite the upgrade process from one JDK version to another. And so as you can imagine, that kind of task, I don't know, yeah, it's not a very exciting thing to upgrade Java versions or to move from RabbitMQ to Service Bus or whatnot. And that's where we hope these tools can really help you so that you can focus more of your time on the things that matter to your enterprise. And so that's it for the upgrade. Oh, this is the last thing. You could download the modernization for Java. Like I said, it was released on Monday. And so you could download the pack. You could give it a shot. You have any issues, you can always reach out to me. I'm more than happy to help. But yeah, so hopefully this will be a tool in your toolbox, in your Copilot toolbox, to really help you become more efficient and effective engineers. All right, thank you. And I'm going to let Julian come and talk about how some of the tools that we used here to build this product you can actually use in your own application. And the hint is that it's got to do with Model Context Protocol. So he's going to come and talk about that.
Thank you, Timothy. So I'm going to show you a modern app. So it's not a migration. The app is already there. I'm going to show you how you can add AI to your application, including with MCP. And what's really fun about this presentation is you will see I'm using the same tools as Timothy. So basically, with Timothy, you are using them to be more performant. And with me, you're going to use them inside your app. So it's like two different use cases of the same technologies, which I find is pretty fun. And so we're going to see how you can build Java apps and deploy them also to Azure with AI inside those apps. So let me just start with a landscape of AI in Java. So it's a very generic slide. There is a lot more technologies, of course, but just to go briefly. If you want to connect to an LLM in Java, there's a new OpenAI Java SDK that was released in final version recently. There's lots, because of historical reasons, there's lots of other SDKs. That's the one which is official by OpenAI. We work on it. Microsoft contributes to it, and I've been also working with them. So that's probably not very used today because it's very recent, but that's the one I believe that should be the most popular in the long term. And when you use an LLM or an MCP server in Java, so you can code everything by hand, using the SDK. But most people today would use a framework on top of it. There are several different frameworks. I just put the two biggest ones. So Spring AI and Longchain4j, they're the two most popular ones. They basically do the same thing. They, of course, both work very well with Azure. I'm personally contributing to Longchain4j, and in fact, I did the OpenAI Java SDK integration to Longchain4j, so that's what I'm going to show you. But I mean, there's lots of other options, of course. Let me start with something very simple. How do you connect your Java application to an LLM using Longchain4j? And so I'm going to do a demo just afterwards, but just to show you how easy it is. Basically, you've got an implementation, so that's the OpenAI official chat model. And you give it basically three parameters. There's a URL, so where your LLM is located, an API key to connect to it, and the model. So here I'm going to use GPT 4.1. If you're on Azure, by the way, the API key is not mandatory. We do the same thing as Timothy showed, with passwordless. If you run on Azure, you can connect with the API key, which is more secure, exactly like Timothy said, but this time inside your app. Well, let me show you a quick demo of this. Come on. Yes. Ooh, flickering a little bit, but it's working. So this is my application. So it's a very classical Spring Boot application. So if you know Spring Boot, it's associated with Spring Boot application. My LM is configured exactly like in the slide. Again, the API key is not mandatory if you're running inside Azure. And I've got a URL and the models that I'm using. How do I use this? Let's have a look at my controller here. So my example is doing an apple pie. It's an easy example to show what you can do with it. So my question to the LLM is, I'm doing an apple pie, give me the list of ingredients. And the way it's configured that I'm using the chat model, I've got this nice Fluent API from Longchain4j. So the good thing with Longchain4j is that this API is neutral. It's an abstraction, so it could work with any kind of LLM. And basically, you send it the question, and you got the answer. So let me run it. Again, that's just a basic use case. So you can expect it's going to be easy. And let me, come on. Here it is. And so let me click on the first demo. If we look behind the scene, so basically, yeah, here it is. It's sending up. So I got the answer too fast. Didn't have the time to copy paste. Here is my message. So we're sending this JSON payload. Let me put it nicely. PB copy. So we send that payload to GPT 4.1, and we got the answer. And so let me show you the answer graphically. So we got the recipe for the apple pie. Very easy to do, like just a few lines of code, and I can talk with GPT 4.1. Now that we've seen that, sorry, let me go back to the slides. Ooh. Let's go a little bit deeper into more complex stuff. Let's talk about model context protocol. So what Tim showed you is what it's called tools calling. It's calling tools that can execute stuff on your behalf. Model context protocol is basically the same idea, but you can call remote tools. So those are running elsewhere. are coded by different people, can be upgraded by those different people. And since that's been published by Anthropic, I mean the specification, it has been hugely popular. So today you've got like 3,000 or 4,000 MCP servers available. There's more and more every day. We do our own MCP servers at Microsoft. Basically, that's also what I'm going to show you. And the good news, if you're a Java developer, is that we've got a very good Java SDK for this, which is developed by the Spring team, by Broadcom, and which was donated to Anthropic. So the official SDK, and I'm going to show you how easy it is to use it. Very easy to create servers. That will be my first demo, and of course, very easy to use them from a client perspective, and that will be the third demo. Those clients, by the way, so it's done by the Spring team. It works, of course, beautifully with Spring AI. It also works beautifully with Longchain4j, which is what I will be using. So let's have a look at the code, and I will do a demo just afterwards about that code. Basically, what you do is you create a Spring Boot project for your server, and so you add a few libraries from in the SDK libraries, and you use basically just those two annotations. The first one, add tool, says that this function, like it's called execute as your CLI, this function is a tool that is going to be exposed, and you should add a description. So the description is basically a prompt that tells the LLM what that function does. And then you've got another annotation, add tool param for the parameters to the function. So basically you tell, this is my function, here is what it does, here are its parameters, and that's all you do. So it's extremely simple to do an MCP server in Java. I'm going to show you this one. And by the way, so this one allows you to run the Azure CLI as an MCP server. So it's an MCP server I did, I don't know, like a couple of months ago. And this got included into the official Azure MCP server. So if you use the Azure MCP server, it's the same code, but it was ported to .NET because it's Microsoft. But the original code is this one, and the prompt is this one, in fact. So you'll see the real one that went into production recently. So let me go back here and come on. So this is my MCP server. So again, it's a Spring Boot application, I would say normal one. And all the magic is here. I'm exposing this method with add tool with a method name, a prompt. I'm going to show you the prompt just afterwards, and some parameters. And that's what the clients to my LLM will discover, and then that's how they will know what they can use. Just let me show you the prompt, because in fact, a lot of the magic here is in the prompt. So we're telling the LLM that this remote function can execute as a CLI, and we give it some instructions about what it should do and shouldn't do. Typically, we tell it when you delete resource, always request user confirmation. That's probably a good thing to do. But let's say, as always, a big part of the job is to have a good prompt so your LLM can use your server efficiently. There's different ways to use this. I'm going to show you first an easy way. I mean, something like a little bit like Timothy. I'm going to use it inside VS Code, and then I'll show you how you can use it inside your Java applications. So I'm going back to this demo here. And if I use GitHub Copilot, exactly like Timothy, you can see, like AIM, I'm using agent mode. I'm using Claude 3.7 Sonnet. And in my tools, so I've got lots of tools like AIM, but I've got this Azure CLI MCP server, which is what I just coded. It's a jar file. And the jar file is available here and exposed as an MCP server. And GitHub Copilot can use it. Let me just show you the configuration. As you can see here, oops, sorry, that's a little bit too small. Yeah, I do something very simple. I use it on the console. I run it as a Java jar file, and well, that's all I do. So extremely simple to use internally. If I want to make it, let's say, more production ready, I wouldn't use the console mode. I would use HTTP mode, so it's available as an HTTP server, which is probably more useful. But for my use case here, that's enough. So I'm going to use it right here, and I'm going to say detail the resources available in the Azure resource group tagged env equal demo. So we're going to see that it's going to use my MCP server. It's going to tell it anyway. So, and the magic here is that now GitHub Copilot is able to access Azure. It's able to access any MCP server that is configured. And that gives it some stuff that it couldn't do at all before. Now it's able to request information from Azure. And it's also able to act on my behalf, so it can create resources for me on Azure. That's what I will do in the next demo. And that's, for me, that's really the power of the MCP servers. The MCP servers allow your LLM to get more information and to act on your behalf. And as you can see, you can install many of them. And so it adds a lot of possibilities and capabilities to like GitHub Copilot or to your application, which is what I will do just afterwards. So yeah, it found my resource group. It's getting information of all the resources in my resource group, and it should give me like a nice output of everything it found in it. By the way, that's the resource group I'm using myself for my demo. So it's going to find my OpenAI instance and my GPT 4.1 models that I'm using, which is pretty fun. As you can see, we're in agent mode, so it's thinking. This is so simple, it shouldn't fail, but if it fails, it's going to retry and learn from its mistakes in order to fix them. And so it's pretty powerful, yeah. So based on the information is everything that it found. So yeah, there's OpenAI, so exactly what we're using for NLM. And after that, there is also some Container Apps instance, because you'll see at the end we'll deploy to Azure Container Apps, so everything is available here. And we've got lots of information. So thanks to my MCP server, now GitHub Copilot is able to read stuff on Azure, and we'll see very soon it's also able to write, to act on my behalf on Azure. Let's move on because, I mean, you can trust that it's all the information I have in my Azure instance. Let me just go back here. So on the client side, so we just saw how easy it is to do a server. Now let's talk about the client side. And on the client side, so you can use a server with a desktop client, so exactly what I did with VS Code. Initially, a lot of people were using Cloud Desktop from Anthropic. That's how it got started. So that also works with Cloud Desktop, which is, I mean, interesting. But you can also use them with an AI framework like LangChain4j or Spring AI, which will be my next demo. So you can give those capabilities to your Java applications. If you've been using those frameworks, so like LangChain4j and Spring AI, you have two concepts which are a little bit older, less than 1 year old, but for AI it's old. That's function calling, so you can call a function that is local. Yeah, basically it's the same code from a developer's perspective. Instead of executing a local function, you execute a remote function, but that's the same thing in the end for you. And you can use something which is called structured outputs, which is also quite recent, which forces the LLM to answer you following a JSON schema. So you can tell it, okay, I'm having this Java object which has those properties, and I want you to answer me following that schema. That's very important when you do tools calling or MCP, because then you force your LLM to have a specific schema that will then map on your Java objects. And that's what you want, because otherwise you can't use that with Java. That's pretty new. I coded that part in LangChain4j. If you try it and see any bugs, don't hesitate to ping me, because maybe I didn't do all the use cases. But for something like, let's say, normal Java Pojo or some records, yeah, we'll use some records. It works pretty well. So let's have a look at how it works. So first, some code in the slide, and then I'll do a demo where we'll see exactly how it works. So we're still doing the apple pie, but this time we want to do something that we couldn't do before. We want to create that file and send it to Azure Blob Storage. So this time, I want my LLM to connect to Azure and act on my behalf using the CLI, the Azure CLI MCP server that I just showed you. And the configuration is a little bit more complex, but honestly, it's not crazy complex. The first 2 lines is me creating my MCP client. So there are 2 transports in MCP. It's either console-based, which is very simple, and which is what I'm using here because it's only local, or HTTP-based, which is probably what most people will want to use when you're in a company. So the first 2 lines is basically configuring this. And the third line is configuring what is called an AI services in LangChain4j, so that's specific to LangChain4j. And as you can see, we've got 2 lines. There's the LLM that we are using, so the same one as before, and then the MCP servers that we just configured. That's a simple example. Of course, you can have several MCP servers, and if you do tools callings, so which are local and not remote, you can also mix them. So here you can have a mix of several local functions and several remote MCP servers, but yeah, basically it's as easy as that. Now, let me go back to my demo, and let's have a look at what it looks like. Let me close this, and let's have a look at, well, the second method here. So, oh yeah, I cheated a little bit. My prompt is much bigger. It didn't fit into the slide. So in the slide I said, oh, you just generated 2 blob storage. If you say this, you know, the LLM is acting on your behalf, and sometimes it hallucinates a bit, so it could create all kinds of stuff. So yeah, I'm a little bit more strict. Oh, by the way, sorry, I should show you what I have in my Azure resource group. Here it is. So I don't have any blob storage. I have nothing. I'm not cheating. It's a real demo. There's no blob storage in it. And if you know Azure, you know if you want blob storage, you need a blob storage account. And then when you want to have a file in it, you know, it's like, I mean, there's different commands to do all of this. And of course, none of those are here. I'm doing this on purpose. It's a little trick for the agent. It's a little bit more complex than just doing a file. So we can see it iterating, failing, and fixing stuff. So we have a nice demo. And so, well, outside of this question, basically that's what we just said. You get an LLM, you've got the MCP server, and you basically run it. So that's created by Longchain4j, so that's just an interface. And the implementation is created by Longchain4j, so you have nothing to do. Let me clean up the console because we're going to want to have a good look at what's going on here. Clear console. And let me run that second demo. So again, we do something a little bit complex, so it will struggle a little bit, and that's the point. So I'm running it. You can see it's sounding lots of stuff. The important thing, of course, is what we're doing at the beginning. Here it is. And then we'll see it struggling and hopefully succeeding. So what Longchain4j did and what did it send to the LLM, it sent my text message as before. The difference with what we had in the first demo is that it's adding all this part. And this part is the function that I'm going to connect to with its description. So it was able to connect to the MCP server, discover what it was able to do, and then basically generate that JSON payload and send everything to the LLM. So now the LLM knows what I want, which is the content, and it knows that it's got some tools, and it knows that this tool can do this, accepting this parameter. So if the LLM is good enough, it's going to, of course, use it correctly. Let's have a look at what it is. So it did quite a lot of things because I didn't have a blob storage account, so it found there was no blob storage account. It needed to create it. It found that we didn't have a blob storage, that it also needed to create a file and send the file. So I'm just showing you this very quickly because there's lots of back and forth interactions. And let's have a look at the final thing. Yeah, it said it worked. So let's have a look here in my research group. If I refresh this, yeah, I've got here a storage account that didn't exist. If I go into storage browser, I've got a blob container that was created. And if I have a look at that blob container here, sorry, I need to click on it first. There should be a file in it. Yes, there's a file in it. And if I view that file, yeah, that's my apple pie recipe that was created by the LLM. So we can see that initially the LLM could only just generate text for me. And now the LLM is able to have a look at what's inside Azure. It's able to create stuff for me. It's far more powerful than what I just had. And again, so that's now included into the official Azure MCP server. So the good thing is that you don't need to code it. Again, like there's a lot of MCP servers being created by lots of people. So while it's easy to create one, as I showed you, I'm not expecting that many people to create them. Like there's already a lot of them existing. What is interesting is that it's easy to use them. And as we saw, honestly, the configuration is pretty obvious. Let me go back to my slides, if it's, come on. There's a few things we need to discuss about MCP, because what we just saw is extremely recent. And there is some limitations on MCP, so I try to do so. That's my own personal list of what I don't like with MCP. The first thing for me is that there's no way today to filter or order those models. You saw it in GitHub Copilot or in my app. It's just a list of tools. And maybe you want some tools to be run before the others. Maybe you want some tools to be orchestrated between each other, and there's no way to do it today. I mean, except by prompting. You can put in the prompt, or only use that tool when the other tool has been run before. but yeah, there's no real good way to do that. You also can't have too many tools. I mean, that's why it's pretty obvious, is like, as you saw, I sent the tool description to the LLM. If I've got like 100 tools, there's going to be a huge payload to send, so it's going to cost you money. But also the LLM will be like kind of fuzzy with all this information that you're sending to it. So there's a need to be able to filter those tools and organize them in order to have the right tools that you need when you need them, and not having just a big list of tools like today. There's a lot of issues on security with MCP servers. Today, there's no, I mean, we're starting to have some registries, so Microsoft is building one, and we also gave it to Anthropic, so that's going to be like a reference implementation, but there's no registry of MCP servers already. So when you want to use an MCP server today, basically you need to download it, like mine. You can go to, I will give you the links at the end, but if you want to use mine, basically you download the jar file and you execute it, and you need to trust me that I didn't put any bad things in it. And I mean, I hope that you trust me, but maybe don't trust 20 people who did 20 different MCP servers. That's probably not a good thing. And so today there's nothing like this. And if you want to be scared, you can have a look at, so the QR code points to that a damn vulnerable MCP server. It's a list of, I would say, the classical MCP servers issues. Classical, that's something that's just 1 month old, but that's how fast it goes. But if you have a look, you will see there's lots of issues with it. And so basically, you need to trust the people who are giving you those binaries because you're going to run them and send your code to them. And so it would be better if we had like a good registry with some signed binaries so you know that, well, basically you know what you're running. There's currently, well, we're starting to have some solution to host them. Typically on Azure, you can host them on Azure Functions. Soon we should, I mean, it's starting to work also on container apps, but there's also some work to do to have them running in the cloud. If you use them with HTTP, in fact, it's like LLM, it's sending you server-sent events, which is sometimes a little bit complex to set up, so we're fixing all of this. Authentication, that was added to the spec very recently, so most MCP servers currently don't have authentication, and of course that's an issue. Yeah, but last but not least, MCP server registries, but I talked about this earlier. So lots of stuff to improve. Then it's very new, and everybody's working on this, so I'm expecting all of this to be fixed, I don't know, at the next build conference, but today they exist. Now that we've seen how I can add AI to my Java application, so connecting an LLM, connecting an MCP server, and all of this in my application locally, of course I want to deploy it to the cloud. And for this, we've got different ways to do, to deploy Java application on Azure. My 3 favorite ones, that's not the only ones, but again, that's my top 3. You can use container apps, which is an easy way to run a container in the cloud. That's the one I will be using, also because I'm using the MCP server, so I've got something a little bit complex. And as it's a container, I can do whatever I want in the container, so that's very good for my use case. If you have something more complex, and still with containers, you've got Azure Kubernetes Service. And if you want something, let's say, easier, like a normal Spring Boot Java application, you've got Azure App Service, which is really good. Like you just give it your Java app. You don't need to do a Docker file, and it will run it for you. So again, here I'm going to use container apps. And when you do this, so my tip at the end, at Microsoft, we've got our own build of OpenJDK, and we have also our own version of Azure. So my Docker file here will be using Azure Linux and our build of OpenJDK. So like you are fully Microsoft in this demo. And by the way, how do you deploy to container apps? It's very, very, very easy. Basically, you need to create an image. So with Spring Boot, you've got 2 options. Either you use the Spring Boot plugin, which works wonderfully well. That's what you should use normally. Or if you want more control, you can use a Docker file. Again, here I'm doing some stuff. Well, you see my Docker file. I'm doing some stuff to install the Azure CLI and so on. So I need a little bit more control. So here I'm using a Docker file for this. And by the way, if you don't know how to use a Docker file, that's not important because you've got GitHub Copilot that will do it for you. So now both options are very easy. Once you've created your image, you need to publish it. You can publish it to Azure Container Registry, which is our own registry, or you can use any external Docker registry. In the demo, I will use Docker Hub, because I'm guessing everybody has an account on Docker Hub. But yeah, basically they all work. Once you've got that image published, you need to create a new container in Azure Container Apps and deploy it. Well, I'll show you how it works, and honestly, it's super easy, and then you have everything running on Azure. So let's do a little demo of this. So let me go back to my application, which is here. So what I want to do is build it as a Docker image. So for that, I need a Docker file. Here it is. So again, my Docker file is using JDK 21 from Microsoft, and it deploys to, it uses Azure Linux underneath. And I've got some, let's say, some tricks here, because I want to have the Azure CLI running, for my MCP server. So that's what makes it a little bit more complex, but nothing crazy. And basically, at the end, just running it as a Java application. So just running Java. So let me build this as a Docker image. Oops. And so I'm going to do image number 14, and I'm going to push it to Docker Hub. Let me just show you my Docker Hub instance, which should be here. So I've got, oh, it's already done. That's so fast. Oh, so yeah, so the Wi-Fi is really good. So it just created my image. It should be here. Yeah, it was already there. Okay, it went so fast, I didn't see it coming. So it pushed my image to Docker Hub. And now I've got my image ready. I'm going to go to my resource group, have a look at my containers. If I have a look here, I've got it already ready here. Oh, hang on. Let's do a new one, because that was already deployed. Let's do 15. So fast. So you see it working. So it's 15, which didn't exist before because I just did it. I create it as a new revision. And what's interesting here with container apps is that I can configure here my resources. So I'm doing 2 CPUs and 4 gigs of RAM because it's a Java app, and honestly, I'm not too careful here because that's just a demo. If you want to be careful on your resources, you can build this as a GraalVM image, which is very small. That's what I usually do. And with GraalVM, honestly, I have very good experience with the lowest resource allocation, which is 0.25 CPU and 0.5 gigs of RAM, which is very small and very cheap. Because there's also a free tier on container apps. So basically here, I'm on the free tier all the time. So it costs me like $2 per month to run this. When it runs all the time, the other tricks that you have on container apps is that you can scale to 0, which I do here by default. So here by default, like when nobody uses my MCP server, it's scaled to 0, so it costs me nothing. And when somebody wants to use it, well, it starts it up, and then I'm only paying for what I'm using. So when I go there, I should have 1 instance running, and if we wait for long enough, it will shut down and just start up again when anybody uses it. And if I go to my instance here, we can see that it's running. And that, let's do the first demo. And we're going to have the same answer as before. Yeah, here it is. Wonderful. So let me just go back to the slide. If you want to have a look at the demo I just showed you, so there's a branch in the resource on the left where you've got that exact demo. That branch is called, of course, build 25. If you go to the main branch, you've got all of the demos. I've got like 15 demos, so you've got more than MCP. You've got like functions calling, structured output, everything. And if you go, well, just in half an hour to the OpenHack, we've got an OpenHack here at Build, which is running so this afternoon and tomorrow morning. And that's the solution to the OpenHack in Java is also in that repository, and there's a branch which is called OpenHack. And basically the same thing, but we do pizzas. So we didn't plan it in advance. I was doing apple pies, they were doing pizzas. But in the end, it's the same thing. And if you want to have a look at the servers that I showed you before, so the Azure CLI MCP server, it's the QR code on the right. We've got 5 minutes left. Timothy, if you have any questions, Timothy and myself were here. Yeah, and you need to stand up and go to the mic if you want to be heard. And well, very happy to answer your question in 5 minutes. And oh, and before you leave, if you want to give us some feedback, yes, there's a QR code here when you can say if you liked that presentation or not.
One thing I
Oh.
Sorry, one thing I do want to add is that for IntelliJ and for Eclipse, we just released agent mode for Copilot Chat. MCP support for IntelliJ and Eclipse is coming very soon as we can get it. And so some of these examples, the MCP ones, they won't work on IntelliJ and Eclipse today. But we will working very hard to get it. But if you use Visual Studio Code, of course, you can. So our goal is to get IntelliJ and Eclipse at parity very soon. So yeah, we'll take questions.
Yeah, I just wanted to know being able to create your own formulas. Are those formulas then shareable to other developers across the organization easily?
Yeah, one of the things that we're working on is actually allowing you to do that by checking it into your repository. So that's kind of like the easiest way to do it. We are looking at like a knowledge base feature in GitHub that might be a place for you to share across the enterprise, but we don't know exactly how that's going to work yet. But you can imagine that that's a very important thing for us to work through. And so as we have more information, we'll announce it. But that is our goal, is to be able to make those shareable. You'll see first it's going to be via a GitHub repository, maybe like a .github/formula directory.
Okay.
And then over time, it'll probably be kind of lifted up.
Yep, awesome, thank you.
Yeah, of course.
So what does a REPL loop for upgrading Java look like when you have a cascading set of dependencies? So let's say you have a GitHub repo, right, and that's your app repo, and then you have a bunch of other repos that are either statically loaded libraries or dependencies. Some of these are 10 years old, what have you, right? So what does the loop look like? And if I can do a part B of that,
Yeah.
maybe you lost the source code.
Oh,
Yeah.
that could be an improvement.
That's if I could kind of like, your question is a really good one, which is, and maybe I could phrase it this way. A lot of the Copilot tools that we've been showing are really repository oriented, like kind of like what you've loaded in Visual Studio Code or Eclipse or JetBrains, IntelliJ, is what it operates on. And really the question is like, well, what happens when you actually have multiple repositories that need to be worked together, right? And we don't have a great answer for that, but I think part of that answer is going to be the SWE agent, right? Where you can kind of orchestrate using GitHub, like, hey, first I want to create an issue that tackles this project, and then when that succeeds, do this one, and then when that succeeds, do this one. And so that's likely the path we're going to go, because our focus for the IDE experience is really what's in front of the developer. And then maybe the focus for the SWE experience is kind of like a more broader orchestration.
Is there a timeline or anything around that?
As soon as we can. So like the SWE agent was released on Monday. And so to give you some transparency, right? Like as Julian was saying, like MCP was really fast, right? So our tools, our migration tools, were built using a Visual Studio tools integration. We didn't have time to migrate that to MCPs for this release. We're going to immediately work on moving that to MCPs. Once it moves to MCPs, and once Eclipse and IntelliJ get MCPs, and all of this stuff will work on that, and then it'll also work in SWE agent. And so I can't promise timeline, but I can tell you that we're working on it right now.
And there's no one around to have an MCP question as well.
Yeah.
So as we look at MCP, REST had Swagger or OpenAPI spec all along, right? You could go read what does it do. I can see that the MCP clients can infer tools as well, but is there a path forward to some kind of a interface documentation for MCP, or is there one that exists?
Oh, so no, so there's not like, well, that was part of my issue. Like, there's not a registry, an official registry where, again, some people are working on this, but that's like one place where you could go and scan and see what it does. Then when you run an MCP server, there's some tools, so the main tool is called Inspector. You can run it, and it will inspect your MCP server, and it will tell you what's in it. But yeah, for me, that's one of the issues. Like, I would love to have a, let's say, website where you got all the servers with some descriptions, and I could search for it. And
I will add, though, that one of the things that we're working on is remote MCPs, right? Like I think Julian touched on required for that. And so with API management, like the Azure API management tool, there's going to be an ability, which I think they released. I've lost track of what was released and what's not. I think they released the ability to turn any REST API into an MCP server. And it's also integrated with API Center, which is kind of like the dev portal, if you will, for APIs. And so check out API management and API Center, and that might be a path for some of those things.
And British API will do it. And anyway, you would need to use those with APIM. So it does rate limiting, it does authentication, because otherwise those servers are just open in the wild. And also, like bad actors could just access the servers directly, not through the LLM. That's it.
And if you come to the Open Hack, one of our friends who works on that product is going to be at the Open Hack. So you can ask him questions too there. And we can introduce you to him.
Yeah, so see you in Alpha now at the Open Hack.
A quick question. Have you tried this with really old Java applications like 1.4, JSP frontends, and that kind of things?
Have we tried these with our own Java applications?
Yeah, old Java applications.
Old Java
So,
applications.
And with front end, like JSP and all.
Yeah. You know, we've tried it with like both internal Microsoft Java applications as well as customer Java applications. I would say, as you can expect with a lot of the, you know, one of the things I didn't say, and that I think is worth saying now, is that because we enhance the LLM capabilities, you know, I would say that, you know, as good as the LLMs are, is kind of like our baseline, right? And what we've seen is that the older the application, the harder it is for LLMs to perform well. But that's where I think what we've done in those cases is we've supplied additional knowledge, right? And so in the case of like I think we were testing a really old Java application once, and what we found was that we had to give it a lot more information about the Java application because it didn't know about it, right? And so that's where we think like the custom knowledge will come in, whether it's going to be authored by hand or whether we can inspect commits or history to learn about the kind of code changes that you're making. You know, that's going to be the path that we're really going to be pursuing. We found much more success with that direction than really like either fine-tuning the model or so forth.
Yeah. And another question. The formulas, to make new formulas, you need to use LLMs like you showed, or you can do that?
You could do that by hand.
Yeah.
You could do it by hand. But we do it with an LLM because it's just a lot easier. The ones that we shipped, though, those ones we did by hand, and we test them. You know, we do a lot of benchmarking on them, and we kind of edit them. But that's, you know, in some ways, if I were to, you know, use a tool to create my own formula, I would probably do the same thing. I would use the tool to start, and then I would look at what it generated, and then I would benchmark it, and then I would tweak it to get better results. But, you know, that's how much effort you put in is how much you'll get benchmark increase. And it depends on how much you want the benchmark to go up, right? Yeah, so, okay.
Yeah,
I think
that's
it for time.
If you have more questions, you can come to see us.
Thank you.
Thank you.